In this lesson, you will compare ratios and solve proportions. And we have quite a few vocabulary today. So first of all, a ratio is a comparison of two numbers by division. A proportion is an equation of the form A over B equals C over D, stating that the two ratios are equivalent, and I'll show you some ways to check that. The extremes in the ratio A over B equals C over D, A and D are the extremes. So if you want to think of if you're going to make an X and you would start here to make an X, those are the extremes, the beginning of your X. The means in the same ratio, B and C are the means. So the second part of your X would be your means. So extremes comes first, then means. Then we have rate, the ratio of two measurements having different units of measure. And we have scale, a ratio or rate used when making a model of something that is too large or too small to be conveniently shown at actual size. And we'll talk about these two a little bit more. So these are a collection of different proportions here. This is the number of restaurants per 10,000 people. And so it's easier to show it in this form, and so we can compare the different countries and the number of restaurants per 10,000 people. So a ratio, there are three ways to show it. One way is a decimal like this. Another way would be like in a fraction. If I wanted to say 0.352 out of 10,000 people, I could show it like that. Or I could use what's called a colon, and I could have 0.352 out of 10,000 people. A proportion would be if I could set up an equality statement. So this is the number of restaurants per 10,000 people. If I multiplied by 10, I would have 3.52 restaurants per 100,000 people. Now this is a proportion because these are equivalent, and I'm going to show you some ways to check that in a moment. So is this a proportion? Well, one way you can check is you can reduce the fraction. Yes, that's 2/3. Reduce this fraction, that would be dividing by 8 to also get 2/3. So you would say yes because you reduce both fractions. I have another way that I think is actually easier. It's called cross multiplying. If you do 2 times 24, you get 48. If this means is equivalent, if I get 48 again, then it's a yes. If I don't, then they're not proportional. 16 times 3 is 48, so this is a yes. So I'll allow you to show either way, but I do think the cross multiplication is easier. So let's check this proportion. I put the extremes in yellow and the means in green so you can see which are which. So I start with the extremes, that would be 30. Like I said, cross multiplying is easier, I'm going to use that. 2 times 10 is 20. These are not equal, so these are not proportional. It's a no. We'll check here. 1 times 30 is 30. 6 times 5, also 30, so this would be a yes. So a lot of what you'll do on your assignment is just check proportionality. Now some of your ratios will look like this. I just wanted to show you that you aren't always going to have really nice looking numbers. I can still do this with decimals. How? Well, start here. Do 0.3 times 2. And then do your 1.5 times 0.5. If they're equivalent, it's a yes. If not, it's a no. So I'm going to put some of these in the notes for you to try so you can practice. Now, to solve proportions, use cross products. As you can see in these examples, I'm missing something, so I'm going to use cross products to solve. Watch. I start with the extremes. X times 5 would be 5x. And then I set that equal to 3 times 10, which is 30. Now I have a balancing equation. This is multiplication. The inverse would be to divide by 5, and I get x is equal to 6. And then you can plug that back in and check, is 6/10 really equivalent to 3/5? And you could just check your proportion if you wanted to. And so 6 is correct. In this situation, I'm going to take 7 times x minus 2. 14 times 2 is 28. Now this is an extra step. You have to distribute your 7 to everything inside. So this would be 7x minus 14 equals 28. Now I'm going to follow my multi-step formula here. So PEMDAS in reverse. Do you see any addition or subtraction? Yep, right here. So I add 14 and I get 7x is equal to, this would be what? 42. Now I have just multiplication, so I did the inverse, which is dividing. So I divide by 7 and I get x equals 6. And if you plug that in, 6 minus 2 is 4. Is 4 over 14 equivalent to 2 over 7? You could do your proportion and check. But yes, it is. And so x equals 6. So you'll practice an example in your notes. Now, a rate is an example of two measures. So some common rates. Maybe you've heard of miles per gallon. That's a rate because it's two different measures, miles and gallons, and I'm making a comparison. You may have heard like miles per hour when you're talking about speed limit. Maybe you've heard of price per pound when you're buying fruit at the grocery store. So in each of these situations, these are different rates. Now, a unit rate is when the denominator is 1. So for example, if I go 100 miles in 2 hours, that's a rate, but it's not a unit rate because my denominator is 2, and a unit rate, my denominator has to be 1. So I can divide that or simplify that, and I get 50 miles in 1 hour, which we would write as 50 miles per hour. So that is a unit rate when my denominator is 1. So that's the difference between a rate and a unit rate. So in the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3 years? So let's write a let statement. Let X be the number of stores. And then what we're going to do is we're going to set up a rate, an equivalency here. So what we have here is 232 stores, and we're going to keep this proportional. So that was 2 years, and I'm going to go ahead and put the labels in here so you can see what I'm doing, but you don't have to have labels in your work. So that came from this statement. In the past 2 years, retailer opened 232 stores. That's one ratio. So now if that growth remains constant, how many stores? See how I put the X above because I need stores to be above? And then my years would go below. It's 3 years this time. Now I just have one of those cross multiplication problems that I have set up. So you would multiply this side and you get 696 is equal to 2 times x. Very basic equation to solve. Divide by 2, and you get 348 is equal to x. Now I just have to answer the question. How many stores would they open if the growth remains constant? That would be 348 stores. So you try the rate problem in your notes. Finally, what is scale? A scale is a ratio on a map. And you'll see scales on different types of drawings as well. But a scale model is something that is done, we call it to scale when the large is too big or the small is too small. So it's something that we create a proportion with. So here's an example. The Ramsey Cascades Trail is about 1 1/8 inches long on a map. And the scale is 3 inches is 10 miles. So I'm going to put 3 inches to 10 miles as my ratio. This is my map scale. What is the actual length of the trail? Well, let's write a let statement. Let X be length of trail. Now this is actual length, and the miles are going to be actual length. So if you wanted to have in miles here to help you with your label, you could, but that's going to be my variable. I know that it's 1 1/8 inches on the actual map, and inches goes on top. I really have to set this up correctly in order for it to work. So do you see how we could then cross multiply here? 3 times x, and then 10 times 1 1/8, and I think that works out to be 45/4 if you do improper fraction. And then I would divide by 3 here, because if I put another fraction under there, that could be confusing to you, but just use your calculator to simplify that, and you get x is equal to 3 3/4. And you can try that on your calculator with me, because I'm doing my calculations already, so if you want to look through that and see how it makes sense, please do so. The label here would be miles, and 3 3/4 miles makes sense, or 3.75 miles, either one would be fine, and so that's the actual length of the trail. So you try a scale problem in your notes.